All right. So this is our Unit 9 review, and this is what we covered in class today. So whether you missed out on it or you want me to cover it again, I'm going to do that right now. Notice this wants us to find the amplitude and period. Our normal functions y equals a cosine of b times theta. It's going to be theta minus c plus d. Okay, there's no plus number at the end, so I can already say there's no d. We're not subtracting or adding anything to the theta. It'd be kind of like in this area right here. So I automatically know there's no c. So I could rewrite this as y equals a cosine of b theta. A is the number in front, so this is just the number in front. So a is 1 over 5. Done. This one's a little bit trickier. So now we have to remember this is being multiplied over here, right? So this is the same rate as saying as 1/2 times theta, okay? 1/2 is our b. That's not our answer though. In order to find our period for degrees, it's going to be period is equal to 360 divided by 1/2. 360 divided by 1/2 is going to give us 720 degrees. So period equals 720 degrees. And that is your final answer. Okay, let's take a look at this one. This one's a little bit easier to see, right? Because there's no fraction. That's going to be your B. This is going to be your A. So your A is equal to 3. B is equal to 6. Okay, stay with me here. For the radians, all right. For the radians, period, it's going to be 2 pi divided by b. b is 6. 2 pi divided by 6. I can divide both top and bottom by 2, so that reduces it to pi over 3, and that's my period. Amplitude is 3. Great. So for this one, even though we have this plus 90 right here, this does not affect our amplitude and period at all. Does not affect it at all. So that's going to be your amplitude. Same thing as before. B is equal to 1/2. You can see that actually 1 and 3 are very similar. You're going to have the same B, okay? So essentially we have a different A, but the same B. So it's going to be the same process. Period is equal to 360 divided by 1/2 equals 720 degrees. And this A is equal to 3. Same with this one. So we can see that this one, the number 2 has just 6 theta. This one has 6 theta minus blah, blah, blah. This does not matter to finding the amplitude and the period. My C right there does not affect it at all. So what does this mean? This means I have to divide out, still have to take out this theta. This is going to be your B. A is equal to 3. Same thing as before. Period is equal to 2 pi divided by 6, which is pi over 3. Great. So with these, just finding the A and the B is going to help you find your period, okay? Let's take a look at this one. So let's remember standard form. Y equals A cosine of B theta minus C plus D. There's no adding and subtracting up here. It'd be like plus 45 degrees or whatever it is. There's nothing right there. So there's no C. There's no horizontal shift. There's also nothing added at the end, like a +2, -2, -1, whatever. There's no D. So we know that there is going to be an A. That's going to be the number in front of this. And then our B is a number multiplied in front of theta. So this is going to be our B. Okay. The amplitude of 4 means that the highest level it can go is 4, as well as the lowest level it can go is 4. Okay. And the period is equal to 4. I need to do 360 divided by 4. And that's going to give me 90 degrees. So my period is 90 degrees. With the cosine function, you're going to start at positive amplitude. So at 0, it's going to be 4. Okay? So your first point is going to be 0, 4, okay? And then it's also going to end at the positive amplitude. I'll put start and end. Okay? It's also going to end the positive amplitude over at the end of the period, which is 90 degrees. The way we know it's 90 degrees is this is 60, this is 120. Halfway between this is going to be 90 degrees. So this right here is my 90 degrees. On the test, I'm going to have everything labeled a little bit nicer, so they're not going to be partials of boxes. So just for this problem, bear with me. But just remember for the test, I made it so there's not this issue. Anyways, okay. So this is up here. And then, so it's going to be 90, 4. Great. So now I need to find a quarter of my period, half of my period, and 3/4 of my period. So at this point, you could put this into your calculator, and you would do 1/4 times 90, or you can always do 90 divided by 4. And that's going to give you 22.5. Half of 90 is 45, and 3/4 of 90 is 67.5. Okay, so this is our x, so it's going to be 22.5. 1/4 of the way through, we're going to be at 0. Halfway through, we're going to be at the negative amplitude, which is -4. And 3/4 of the way through, we'll be back at 0. This comes from the chart that we already made. So we talked about a quarter of the period, half the period, 3/4 of the period. Because it is cosine, that's where it's going to land. So this would be 30 degrees. Halfway through between here is going to be 45 degrees. Okay? I know this gets a little tricky for this one, but like I said, bear with me. So we have 22.5. So right here, this would be 30 degrees. So just do a little bit before 30 degrees, right? So maybe something like right here, okay? And right here. So maybe like a quarter of the way through, okay? Now we continue the pattern. Go down 3/4 of a box, go down 3/4 of a box. Then I go down another 3/4 of a box. So a quarter here and half here. So a quarter here and then half here. Go through the other half of the box, go a quarter of the way over. And then on the next line over, we're going to end up back at the positive amplitude. Okay, so our positive amplitudes, our positive periods are going to be 90, 180, 270, and 360. Okay, so we know that it's going to have a full function in between each one of these dots over here. You can also eyeball it, right? So half of here is 1.5 over. Halfway between here is like 1.5 over. And then, like I said, about 3/4 of a box on each side. Oops, sorry, that was actually over here. Actually helped to like label it over there. Makes it a little bit easier. Okay, so it's going to look something like this. Okay, does it need to be perfect? No. The most important thing is to get these numbers over here. Like I said, these numbers are not going to be fractions or partials of a box on the test. Just for the sake of this review, we just did it just to give you guys a little bit of a challenge. Okay, so tangent. So remember, the laws for tangent are a little bit different. So tangent periods is where it crosses through the x-axis. Okay, and then we also need the asymptotes, and we're going to use the odd multiples. Okay, so for this one, the period. Now remember, the period for cosine and sine is going to be different than tangent. So the period is going to be either pi over b or 180 divided by b. Okay, and then the asymptotes is going to be either pi, I put the 2 too soon, pi over 2b or 180 over 2b. Okay, we're using degrees. You can see all these down here are degrees, so that's where we're going to be using. So for my period, it's going to equal to 180 divided by 1/2. And that's the same as saying 180 times 2, or you can put in your calculator 180 divided by 0.5. Either way should give you 360. So I know my A would cross through at 0, 360, 720, etc., right? Our map ends at 540, so we're not going to do 720. We're just going to do 0 and 360. So basically all multiples of 360 is the period. Okay, now for the asymptotes. So it's going to be 1, so that's the period. Okay, it's be 180 divided by 2b, and b is 1/2. Okay, looky here. So 2 times 1 over 2 is equivalent of 2 divided by 2, which is 1. 180 divided by 1 is just 180, okay? So we need to go in sets of 180. So it's going to be 180, 360, 540, etc. And we would continue to carry on. I do see that we end at 540, so I'm just going to end it right there. And we're doing odd multiples, okay? Odd number, 1, 3, 5, 7, 9, 11, blah, 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 blah. We only have 3. So it's just your first and your third, okay? Those are your asymptotes. So those, you're going to create a line going up and down. Wee. Okay, we did the hard part. Now we get to do the fun part. Anything to the right of this dot right here is going up and to the right. Anything to the left is going down and to the left. Okay, same with this one. This is just basically to the right, so we're going up and to the right. Remember, do not cross that line. And this is your answer. Okay, let's take a look at number 7. So cosecant. So first we have to graph the sine of 2 theta. Remember, cosecant is associated with sine. If it was secant, you would do cosine. If it was cotangent, you would do tangent, okay? So we're going to graph sine of 2 theta. So A is equal to 1, okay? So there's no amplitude just right here, okay? Our B is equal to 2, so my period is equal to 360 divided by 2, okay? And 360 divided by 2 is going to give me 180 degrees. So if I'm graphing sine, it means I start at 0, ends at 0, okay? Half of 180, so we can do a little chart down here. So we're going to do 0, 0, 0, 180, okay? 1/4 of the way through, so 1/4 of 180 is going to be 45. So it's going to be 45 degrees. It's going to be at the positive amplitude, which is 1. Okay, and then our next one halfway through is going to be 90. It's going to be at 0 again, so 90, 0. And then 3/4 is going to be 135, -1. So this is going to be half of the period, quarter of the period, half of the period, and 3/4 of the period. Okay, great. So this would be 30 right here. We already know this is 60. Halfway between 30 and 60 is 45. So this would be 45 right here, okay? Just as a heads up. So you're like, where is she drawing these lines? Okay. 45, 1. Okay. And at 90, 0. And at 135, -1. You can see the pattern. 1 1/2 to the right, and 1.5 up. So continue the pattern, 1.5 to the right, 1 up. Then we go 1 down, 1.5 to the right. Okay. And then 1 down, 1.5 to the right. And then 1.5 to the right, 1 up. Great. This is going to be our sine function. So we have 2 more steps after graphing our sine. Okay. The first step is to create asymptotes. And we're going to create it at where the function y is equal to 0, or on the x-axis. Okay. So literally like right here, see how it crosses right here through the x-axis? We're creating a line. There's another one right here. See how we're crossing through the x-axis? I'm going to create another line through here. Same with right here. There's a line crossing through the x-axis. I'm going to go ahead and create an asymptote. So you just continue the pattern, okay? And then step 2 is we're going to reflect the parabolas. So let's take a look over here. Let's make it a little bit thicker. Okay. So you can see there's a point right here. It kind of looks like an upside down U. So we're going to create a right side U up this way. This one looks like a U. Then we're going to reflect and create an upside down U. Okay. Fantastic. So this is going to be our cosecant function, okay? And we got 2 more problems left. Okay, so this one, y equals a sine b of theta minus c plus d. Okay, so there's no a. Our a is an imaginary 1, okay? That also represents our amplitude being an imaginary 1 at first, as well as a negative 1, okay? There's no number multiplied in front, so we're just going to assume there's an imaginary 1. Well, we know there's imaginary 1 because we know if we want multiply 1 by theta, so it gives us theta. So our b is 1. Notice right here, and I'll do this in red, our actual function says minus c, and I see a plus over here. So what that means is our c is actually a negative number, so that means we're going to the left. So c is equal to negative 3 pi over 4. Remember, this negative here times this negative right here creates this positive over here. Okay. And that's going to be our horizontal shift to the left. Okay, we see this plus 2 right here. That means we're going down 2. Okay, so once again, sine starts at 0. And we know our function ends at 2 pi. If you look at our original chart, you'll be able to see where they're supposed to be. So it should give you these points, 0, 0, pi over 2, comma 1, pi, 3 pi over 2, comma negative 1, and then we continue the pattern. Because our b has not changed, there's no need to go or graph our original one different. Okay, great. So this would be like 1/4 or 0.25. This would be like 1/2 or 0.5. This would be 3/4 or 0.75. See how each one's about 1/4 of pi? It wants to shift to the left by 3 pi over 4. So it would be this one right here. So we could move over 1, 2, 3. We're going 3 to the left, and we just measure it that way just so we know the size. So it's going to be 3 to the left. They're like 3 boxes to the left. So let's put that. 3 boxes to the left, 2 boxes down. Okay, so I'm going to take each individual point, and then I'm going to regraph it. So let's do a little bit thicker so this stands out. So I'm going to start right here, okay? And then it's going to be 3 boxes to the left. 1, 2, 1, 2, 3, down 2, 1, 2. I know I'm kind of off the graph, but it kind of helps keep me track of what we're doing. Okay, this one right here, 3 to the left. 1, 2, 3, down 2, 1, 2. This one right here, 3 boxes to the left. 1, 2, 3, down 2, 1, 2. This one right here, 1, 2, 3, 1, 2. This one right here, 1, 2, 3, 1, 2. This one right here, 1, 2, 3, 1, 2. And this one right here, 1, 2, 3. Oh, I already did that one. And this one right here, 1, 2, 3, down 2, 1, 2. Should look something like this. And we can continue our pattern, right? We're going to go down to the 2, right one, and then start heading back up. Okay, perfect. So that's going to be this function right here. All we did was a vertical and horizontal shift. Okay, let's take a look at this one. This is going to be our A. B is equal to 1/4. C is going to, we have to divide it out. So it's going to be 135 divided by B. And then I'm actually going to add some extra notes for you guys to be added on the test if you guys want to take it. But it kind of discussed that we have to divide out our B from it in order to get our C. And this is going to be our D, which is a -1, so down 1. Okay, so we're going to start off with our original amplitude. So we have 2, and we have -2. Okay, and our B is 1/4. So the period is equal to 360 divided by 1/4. And it's also equivalent of 360 times 4. So 360 divided by 0.25, or 1/4, is 1440. Okay, this is a cosine function. Remember, cosine starts at 0 amplitude, so it's going to be 0, 2, and ends the period, which our period ends at 1440, and ends our amplitude, which is 2. So I can mark those points. Okay, half of 1440 is 720. Okay, and at 720, we're at our negative amplitude, which is -2. 1/4 of 1440 is going to be 360 degrees. So at 360, remember 1/4 of a cosine period is going to be at 0. So I'm going to be 360, 0. And then 3/4 of 1440 is 1080. Once again, at 3/4, it's going to be our y is 0. So it's going to be 1080, 0. Okay, you can see the pattern, right? Right 2, down 2, right 2, down 2, right 2, up 2, right 2, up 2. So you're going to continue that pattern. Right 2, down 2, right 2, down 2, and then you can continue up right 2, up 2, right 2, up 2. You can really continue on for forever. This is just helping us get through this. Okay, let's take a look. So we've done our A and our B. We've graphed it with our period and our amplitude. So now we're going to graph it with our horizontal shift. So C is equal to 135 divided by 1/4. Okay, we said that up here, that we have to divide out our B in order to get our C. So 135 divided by 0.25 is going to give me 540. Okay, this is a negative, so we're going to the right. Okay, and you can see right here, this would be 180. We already have a label up here. This is 360. And right here would be 540. So we can see we go 1, 2, 3 to the right. So 3 boxes to the right. And then up here, we can see we have a -1 and down 1 box. Okay. So we take this, go to the right 3, 1, 2, 3, down 1. Take this, right to 3, 1, 2, 3, down 1. Take this, 1, 2, 3, 1. Take this, 1, 2, 3, down 1. Take this, 1, 2, 3, down 1. Take this, 1, 2, 3, down 1. It would be somewhere around here. Okay, we continue the pattern, right? So since we're at our peak here, we can start going down. So down right, I'm sorry, we're going to go to the left 2, down 2. And then we would go left 2, down 2 again. So it would end up somewhere around here. And then essentially you could continue on that pattern for forever. So that covers all the example problems. Hopefully this helps you and potentially helps you finish up some worksheets as well.